So our lesson today, or our lab today, is going to be the sticky tape lab. And you're literally going to be playing around with sticky tape. But what I want to talk about first, and you need to know this before we start, is what charges are, how we build charge, and why there's attraction or repulsion, and that force that charges have. So first of all, we need to know the structure of an atom, which you should have learned in chemistry, whether you remember it or not. This is what we're going to learn about today. And this isn't the most recent understanding of the structure of an atom. It's very much like the universe and the galaxy, where the structure of the atom has evolved over time. It started off as just blocks of matter, and now it's evolved into protons and electrons with electron clouds traveling around it. But here's the basic understanding of electrons. We've got protons in the middle and electrons traveling around the nucleus. So the electrons, if you notice, are on the outside. Because they're on the outside, they have more mobility. The protons on the inside cannot move from the atom, so those stay put. So if the protons stay put, how do we develop positive charges and positively charged items and negatively charged items? Well, the positive and the negative charges don't mean that the object is only electrons or only protons. It just means that there's more protons or more electrons than the other. So if we have a neutral atom, and that's generally what atoms want to be, we've got the same amount of protons than electrons. Now, in this scenario, we've got 2 electrons and 3 protons. We call this a positive charge, not because there's only positive charges, but because there's more positive charges. And we also consider it electron deficient. We always focus on the electron part of it because electrons are able to move. Here we've got the same amount, and like I stated, this would be considered neutral, meaning the same amount of protons and electrons. And then here we've got a negatively charged object because there are more electrons than protons. So this is what we consider an excess of electrons, whereas the previous one we considered electron deficient. We never talk about proton deficiency or excess protons. We only consider electron movement, and so that's why we focus on the electron deficiency or the excess of electrons. All right, there are only 2 types of charges. Obviously, there's neutral, but there's a positive and a negative charge. That's when you'll start to see some forces applied, because positives and negatives will repel or attract. And just like in relationships, opposites attract. Just like with magnets, opposites attract. And like charges will repel. So I had this little animation here with a positive and the negative attracting, which doesn't work today, but distance is a huge factor on how large your force is. I had my balloon that was stuck to me. It's a pretty small force. I could pull it off pretty easily, but it was able to stick there despite the force of gravity, despite the force of the wind. So there is definitely a force, but it needed to be really close to my body in order for that attractive force to happen. So if I had it further away, just like magnets, the further away you have it, the less you feel the force. The closer it is, the heavier the force. Regardless, those forces are going to be really small. And so you're going to have to know how to use your exponents when you're calculating these force values. Here, we talked about conductors and insulators. Here, we've got a list of objects that tend to be more negatively charged versus positively charged, and this is going to be important in your homework. So these objects up here will tend to be more positives. They're going to give up electrons a lot more than these objects down here, which like to gain electrons. They attract electrons a lot more. Whereas these, they're happy to give their electrons away. So this is going to be important for your project, for your homework. But I want you to notice there's a lot of metals, nickel, brass, and gold, that are down in the negative charge section, which is why we consider metals generally good grounders. But also notice there's PVC, which is plastic, silicone, Teflon. Those are also objects that like to pull electrons. So those are also good grounders. So to start, we established that, at least I hope we did. How many of you established that the top tape was positive? Okay, good. You should have. If you didn't, then there's a video I'm going to post to watch the video, to watch this lab again. But the top tape is positive, bottom tape, they attract it, so the bottom tape is negative. Now, they only develop that charge once they are stripped off each other. So in between, from this point on, you should have some negatives mixed in with positives and positives mixed in with negatives. It's only until they split that the positives and the negatives separate. Now, the PVC pipe was negatively charged, and that's how we figured out that the top tape was positive because they attracted, and the bottom tape was negative. The lucite was positively charged, and so we should have seen an opposite reaction. But we also noticed that the neutral objects, the paper and the foil, they didn't have an attraction to each other, but even being neutral, they had an attraction to a positive and a negative charge, right? Hopefully. So, what's happening? If an object is neutral, it should have the same amount of protons as electrons. So notice here we have the same amount of protons as electrons. But when a charged object approaches it, the electrons, even if they're not free to move from atom to atom, they are able to move within that atom as close to the positive charge as possible. So your electrons are going to go closer to this positive charge to the left. And then up here, it doesn't really matter. Your positive and negative charges are not feeling the attraction yet. So from down here, I want to see that your electron within the atom is close to the proton. Now, if we had free-flowing electrons, I want you to notice that we've got 2 positives and 2 negatives in each atom, which is fine. But because my electrons are free-flowing, I'm going to take these electrons down here. Instead of making it even, my electrons are going to repel. So my 2, 4, 6 electrons that I had down here are going to move to as far a position as they possibly can get. So 2, 4, I need one more, 6. Does that make sense? If it's free flowing, it means that your electrons want to move as far away from the negative charge because like charges are going to repel. Now the proton stays put, so every atom should have 1 or 2 protons. They generally like to stick in the nucleus. And then the electrons can either move around in the atom, depending on the material, versus move between atoms as far away as possible in this diagram. So my next lesson is going to talk about how different materials have different properties of either free-flowing electrons versus non-free-flowing electrons. So let me get that open for you. So here we talked about the order in which objects either absorb electrons versus get rid of them. And this is something that you're going to look at in your homework today. But we, from our lab, not only understand and have proven the fact that like charges will repel, positive or negative, and opposite charges will attract, but we've also come across the fact that neutral objects will attract charged objects. And there's no effect when you have two neutral objects interacting with each other, right? So, what happens is the development of how we understand the anatomy of an atom has developed over time. It started off as blocks of matter, which we know is not the case. Then it evolved into having some sort of charge. But now we know that we can have positives and negatives, and it's evolved into these spherical systems into something even more complex like this. For the understanding of how charges work in our class, we're going to stick to this model, and it basically shows us that the proton is in the middle and the electrons are a little bit more free-flowing because they're in the outside of our atom. Here, I'm just emphasizing the fact that protons have positive charges. The proton is tightly bound versus electrons, which have negative charges, and they're weakly bound, meaning they're free to move. And in insulators, I just used an example of my insulating cup. When we talk about insulators, we talk about them in terms of temperature, right? This is going to keep my water cold. If I have ice in it, it'll have ice in it all day. Or it'll keep my coffee hot. Insulators, just like what we use when we're drinking out of an insulating cup, it'll hold charges much better than conductors. And insulators do not allow their electrons to travel as much versus conductors, such as metals, which allow our protons and allow our electrons to travel through it. So when we talk about grounding, like we did in our warm-up, generally your conductor is going to be metal or some sort of conductive material that can pull charges off of you. In this demonstration, this one right here, we had something called polarization, meaning the positive and negative charges go on opposite ends of each other, just like the poles of a magnet, right? So polarization is what happens when you have an insulating object, but it still attracts things because the positives and negatives can move on opposite sides of the atom to create two different poles. Whereas some molecules have charges that are just free to flow wherever they want to. I've got a couple of videos. These are good videos to just demonstrate the repulsiveness and attractiveness of charges. The first one is an activity you can do from home. So we've got some running water. We could have done it in class with our PVC pipes, but we only have one sink. And a comb, which I'm sure you all have. And it's very similar to material as the PVC pipe we use. But he brushed his hair, or she brushed her hair. And if you look at the bottom of the water, you can see that bottom of the water bending because it is attracted to the charge of the comb. The water's not charged, it's neutral. But as the person brushes their hair, it charges up that comb and it attracts a neutral object. So this is something you can do at home. This is something you cannot do at home. So Obviously, it's in the title, fire caused by electric charge. How many of you guys have been shocked but actually saw the spark that left your finger? All right, so basically, generally you feel a little bit of pain, not too much. You see a little bit of a spark, but when you do it near something very flammable, like gasoline, it is no bueno. So she's not doing anything abnormal. She's just pumping her gas. She's going to get in her car because, we don't want to stand around all day. But unfortunately, she's in an area where the air is dry and charges can transfer. And so the contact and the rubbing between her bottom and the seat create a buildup of charge. Nobody was hurt in this video, but that little spark that you get when you get an electric shock, it can be dangerous. So what I'm saying is, anytime you build up charge, that charge, when you touch something, is going to ground. It's going to go into something else that is not charged. And that transfer of energy, that transfer charges is a transfer of energy. It can create fire if you have something flammable around you. And then the last thing I want to talk about is homework. You've got 2 sets of concept builders, but you only have to do 1 concept level here and 2 levels here. And you have a set of notes that aren't due till after break, but there's quite a few parts to it, so I would start it now. On top of that, pay attention because I've got some extra credit. I've got an extra video that is optional, but it's easy to do. Basically, you're going to take that set of notes when you watch this video on a piece of paper, and it's going to go into your next packet. So at the bottom of your packet list, I'm going to put extra credit video notes, and you can get 10 points for that on your next packet. All right? So for those of you who can't keep up with homework or just need any things that you can get, I recommend that you do take these notes on your own. Any questions? All right, you guys are good to go?